We saved your Matt. We saved your seat.
Oh, there's a seat.
At the framework adjacent table.
That's the old team
What? Past and present framework team.
All right. That's weird.
You need a smell the entire room. I like it.
Hopefully.
It's citrus, man. That's fine. It's not like it's fish or something.
My microwave tuna.
Hey, hey.
All right. No. I just wanted to make that one. I'm just gonna have the citrus one now.
From my point of view, this has
So now you just have to get 54. Now you just have to get 54 questions right.
Pretty fun.
Just trying to make eye contact.
Alright, here.
Yeah.
Are you checking the live stream on this?
I'm glad I can.
Could you please?
Yep.
I want to make sure we're streaming.
That was the.
It's in the email.
That's right.
Distracted.
Alright, while he's looking that up, welcome everybody. Thank you for coming. This is the AWS Certified Developer Bootcamp. Now, my goal in the end of this is to give you about 80% of the way for your certification exam. So, can I get a show of hands who all used AWS? Handful? Okay. Anybody not know anything about it? One? Okay, cool. Well, we're going to jump in.
It looks good.
We're good?
Yep.
You see the slides?
I am.
Cool. All right. My name is Steven Saley. I am a software engineer here at First Data Bank. I am a self-proclaimed AWS aficionado. So I have put a lot of time and effort into learning AWS and to get familiar with it and see how we can use it as a solution to a lot of the problems that we run into today. I've got 4 of the current 7 available certifications. So I've got the developer, the Solutions Architect Associate, the SysOps Associate, the DevOps Pro certifications. And I'm actually going in like 2 weeks to get my Solutions Architect Pro exam. So let's talk a little bit about certifications. Certifications, there are, I guess there's technically 8 in total. There's this Cloud Practitioner, which is your foundational. I can't get that one actually because if you have any other certifications, you're ineligible to get that cert. There are 3 associate level certifications, and they're kind of the stepping into for different user groups. So your developers, how are you going to implement this? Solutions Architect, how are you going to design a solution for whatever your need is? SysOps is much more like operations. Then you have your professionals, DevOps, and that's your hybrid between SysOps and Dev. It talks a lot more like about deployments and troubleshooting. And then your Solutions Architect Professional, which is a much deeper dive into cost management and proper infrastructure management, scalability. And then there's 2 specialty ones. There's the Advanced Networking, and there's Big Data. The developer exam, it's multiple choice, multiple answer, 80 minutes. That's about $150 to register. There are some sample questions provided that don't cost at the link, and there's an exam blueprint, which is kind of what to expect for this certification. For the scope of this course, I'm going to be covering most specifically the things that you're going to see on the developer course. Keep in mind, there is a lot more to AWS than just covered here. By the way, Aaron, how are we on sound?
I don't know. I haven't looked at it.
Okay.
I'm assuming it's going to host things up if I start playing sound in here. So.
Just making sure. All right. So, what is AWS? Let's talk about the basics of AWS. AWS is a cloud platform hosted by Amazon, and they've actually got some videos that I'm going to try to provide or to show that will help provide you a little bit more information about it. So let's hope this works.
State. With financial data or photos, your business depends on applications that run reliably and securely at a cost that scales with your needs. Amazon Web Services provides a complete set of cloud computing services accessed via the internet to help you build and run those applications. At AWS, we provide compute, storage, and database services which enable your organization to quickly provision the IT resources it needs without significant capital investment.
Okay, that is not working. I will send out the links for those, and I'll try to get that better for tomorrow. It's just talking a little bit about what cloud computing is itself. Talks about how they, being Amazon or Microsoft, Azure, Google, there's a couple others like DigitalOcean, how they provide the hardware, and on top of it is where you can usually pay per need to spin up resources. Yeah, like I said, I'll send out the links for the videos. It's kind of the issues you get sometimes with posting things live. So let's talk about what makes up AWS from a high level. And there's really two kind of things that we're going to talk about, and it's regions and availability zones. So regions, they're geographical locations that AWS hosts data centers. So currently in the United States, there is a region in Virginia, in Oregon, in Northern California, and the most recent one for the US is Ohio. Now within these regions, there are availability zones. These are the actual data centers within that region. Usually there's 3. Sometimes there's as low as 2, and I think Virginia has up to 4. You're not going to be tested on that, but you do need to know kind of what is a region, what is availability zone. These are isolated data centers though, so if disaster strikes one, if one catches fire, it's not going to affect the others. Accessing AWS. You can access it through 3 primary ways. The management console, which is their website. The CLI interface, and that you can get that on Linux or Windows. And then their SDKs. And there are several, such as Java, Go, C#, Python, Ruby, Node. Yeah, you can look that up later as well. And then finally, let's talk about tags. I'm going to bring up tags because it is an important part of this. Tags are kind of an underutilized tool that you can have in AWS. So you can tag your resources, whether it's a EC2, and I know we're talking terminology right now, and we'll get to this later, but virtual machines, EC2s, you can tag those with different information, such as a name or a type or a product. And it's just key value metadata. Some of the benefits to keep in mind with these is that you can interact with resources. So for an example, you can use tags with Lambda, which is a serverless compute operation, to shut off EC2 instances at night. You can track resources. You can create what's called resource groups and group things by tag so that you have insight into your environments. So maybe, for instance, a prod environment, you could look at your virtual machines and your databases and any other resources that you have with those. And then also you can use them to track spending. So you want to know what is the cost of your prod stack specifically. You may have several stacks in your account, but you want to track something in that account specifically. All right, that's it for the basics so far. Any questions? Yeah.
Can you put the multiple tags in one resource?
I'm sorry, say that again?
Can you put the multiple tags in one resource?
You could have multiple tags on each like AWS resource. So an EC2 can have multiple tags. Resource groups are usually, I want to group everything that might have a tag of type prod. Does that make sense?
Yeah.
Does that answer your question?
Yeah.
Okay. Okay, we're going to jump into it if nobody else has any questions. And we're going to start off with IAM. IAM is one of the core services provided by AWS, and it's Identity Access Management. So, what is IAM? And I have a video for this. Like I said, I'll send out the links and I'll try to get these working better for tomorrow. IAM is access management for an AWS account. So what are some of the components of IAM? You have your users, and these are people or programs that are external to AWS that may need console access or programmatic keys. An example of which might be I, as a user, have a user in IAM. But also you may have something like Sumo Logic, or there's like Alert Logic, or there's several other third-party providers that may need programmatic access to do something in your account, and sometimes you'll set up a user to get those programmatic access keys. With your programmatic access keys, you get your access key and secret. Also, with console access, there's an account ID, a username, and a password. It should be kind of similar to most things that we do. Groups. Groups are collections of users. The nice thing about groups is that you can manage access at a group level and not just a individual user level. So, admins, maybe a group. You may want all admins to have specific permissions within your AWS account. But you don't want to have to go to 20 different people. I hope you don't have 20 people in your admin group, but
You do.
yeah, well, that's a different issue. But you may want to manage them by just adding or removing them from a group and stating that that group has a certain policy. And we'll talk about policies, but permissions. Roles. Roles are access management for other AWS services. So they're very similar to users, but they are specific to an Amazon service. So for instance, EC2, your virtual machines, you can attach what's called a role, and it will manage the access key and secret under the hood. So it still gets access to the other services in AWS, but you're kind of offloading that key management to Amazon themselves, and you're not storing any keys on the box. Best practice: use roles, not users, for programmatic access to AWS resources. And then policies. Policies are kind of the really fundamental part of IAM, and these are JSON documents that will enable permissions throughout AWS to be given or restricted to users, groups, or roles. So you can either choose to give a user allow permissions or deny permissions in a policy. So you create this policy, and it might state that I want to give all users that are attached to this policy full access to S3, which is the object storage, or full access to EC2, so that this user can do anything with EC2. Excuse me. All users, groups, and roles are created by default with an implicit deny. So when you create a user and you do not attach any policies to them, they have no access. Finally, this is an example here of the Amazon S3 read-only access policy. And we have a statement which says that we have an allow. So we're allowing any user that has this policy attached to them get and list access for S3 to any resource in S3. So this is read-only permissions to all of S3. Questions? It's a pretty high-level covering of IAM. It's very important, but it's not very deep. Now you can go very deep into your policies and how you restrict and give access. Policies are very powerful in what you can allow to have happen, but for the scope of the developer exam, you don't need to worry about that too much. So,
Can you have conflicting security?
you can. Now,
So Stephen,
yes.
can you restate the question? I think the stream's having a little trouble hearing us out here.
Okay, sure.
So,
The question was, can you have conflicting access policies, right?
Can a user have conflicting policies?
So can a user have conflicting policies? They can, but a deny will always override an allow. So if you have a policy that says I'm going to allow full access to S3, and you have another policy that says I'm going to deny full access to S3, then the deny will always override that allow. Any other questions? Okay. So we're going to jump into STS. STS is kind of a sister service to IAM, and it's the security token service. So, also, let me go back real quick. In your study guides, you'll see some fill in the blanks. The things that are in red on the slides are the answers to those fill in the blanks. If you need pens or anything, there's pens on one of the tables back there. Feel free to grab them. But we're starting to get into the fill in the blank sections. So, I'll give everybody a second to catch up. Were you able to hear it?
I can understand.
Okay, that's fine. Okay. STS. It's an extension of IAM that allows for the creation of temporary security credentials. So no users are required. Permissions are inherited from an associated role. So this is kind of the blending between giving people access and roles. STS doesn't make you, it allows you to give somebody temporary access without having to create a user for them. A scenario that might make this a valuable thing would be, say you have a mobile game, and you want people to be able, through their mobile game, to write a record to a database. Maybe it's the current level they're on with their high score. Do you want to give a user to every single person in the world that uses your app? Or would you rather give them a temporary restricted set of credentials that you set up the service but don't have to manage the user? I would think that you would want to use the temporary credentials. So STS permits you to create those temporary credentials. They're very short-lived, and after a while, depending on what timeout you set, they will time out and they no longer have access, but you associate a role. So you would write a policy and attach to a role, and let's stick with the example that we had with a mobile game writing to a database. Your role might have write-only access to a specific table in your database. And you can restrict it like that with your IAM policies that you've attached to that role. So the user would then assume that role, and then they would be able to write their record. And this is all done invisible to the user. This is done through their application, and then their user writes that record to the database and continues on with the game. So there's two real examples that they cover, or ways that they use STS in the developer exam, and these are Active Directory Federation and Web Federated Identities. So we're going to talk, and this is your first fill in the blank here, Active Directory Federation. So Active Directory should sound familiar to most people, Microsoft's authentication server. You can use an on-prem Active Directory ADFS server to gain temporary access to AWS using SAML. SAML is short for Security Access Markup Language. And here's the steps. So I'm actually going to start here on the whiteboard. Okay. All right, I switched over to the video feed. Make sure it switches, please. Let me know if it doesn't. Sure. Okay, so it is important to remember the steps for this in the developer exam. So we're going to talk about active Okay, so the steps for the Active Directory Federation is a user accesses a web page on an ADF server. So this is step one. The user logs in here, and then the server will return back to the client browser a SAML assertion. This is stating, okay, I've authorized this user through my ADFS server. I'm probably in the way of the camera. The ADFS server, and I am now giving this SAML permission back to the client browser, stating that this is an approved user. This is used with the assume role with SAML API call to get the STS token. Assume role remember this call, this will come up in your exam. This is what gets you your STS token. So that was step 2. This here, step 3. And then, so users got that token here. Let's just indicate it with a little key, which is a really horrible looking key, but whatever. Once this STS token is gotten, it is then routed to a sign-in URL for AWS. Step 4. So it's important to remember that the user always authenticates first through their ADFS server. They will get a confirmation from that server stating that yes, this user is permitted to do this, and I've authorized or I have authenticated who they are. You then call STS services to get with that assume role with SAML call to get your STS token, and then that token is used to get you into AWS. Any questions? No? Cool. All right, so we're going to talk about the second. Anybody else want to see this real quick before I erase it?
Stephen, on the AWS sign-in, do they have to re-enter their credentials?
The whole point is they don't have actual AWS credentials.
They've got Active Directory credentials.
Right. So, but AWS won't know those.
No, it should, and I've not had hands-on with this, keep this in mind. You should get that SAML URL, and then that should be what directs you and logs you in. I don't believe you have to add to give a second set of credentials.
So it's not really a sign-in page as much as it's access to AWS.
Yeah. It's
to
that
bypass the sign-in,
Correct.
like the type in
Yeah.
username, password type.
Correct.
Sign in.
Thank you for clarifying that. Does that answer what you need? Okay. All right, if anybody needs this still, let me know. Otherwise, we're going to jump into Web Identity Federation. So Web Federated Identities, or Web Identity Federation, is very similar to the Active Directory, except it uses third parties. So Google, Facebook, OpenID providers. Every website that we pretty much see anymore that says log in with your Google or Facebook, this can be done through AWS. So this is the ability to use third-party providers, like I said, Facebook, Google, OpenID, to grant permissions without giving user accounts. So the steps. User. Probably could have kept my little user guy. He's happy. They're going to go to your third party. Like I said, Google, Facebook, doesn't really matter. They are going to authenticate with the third party. Yes, I am Steve. Third party, so that's step 1. Third party, then will provide a token. This is your, with the assume role with web identity. Make sure that you remember which of the assume roles it is. So Active Directory is assume role with SAML, and Web Identity Federation is assume role with Web Identity. So you get this token back. This is step 2. And this gets you your temporary credentials for AWS. This is your STS token. You will then use the temporary credentials that you get with that token. They are your access key ID, your secret access key, and your session token. And you can use that with the, so use STS creds for your SDK, CLI, and whatever you're trying to get into. So you may have written an application. Let's go with the mobile app that we talked about, where a user puts their high score up. You would then use the keys from the STS token with the SDK that you wrote the app in to give access to that. Questions? Okay. All right. Let's jump over to the slides again.
Yeah, I do. Are you assuming that the user then is going to log into the third party?
You use the
that
token.
they're going to be logging into your game using Google or Facebook, and that's their user credentials from Google to log in to get a temporary ID?
So, and correct me if I understand what you're saying correctly. User's going to go to Facebook, and this is very similar to GitHub and some others that use the third-party login. You get redirected to the third party. The third party is what handles the authentication of the user. Now you have a tie between with your STS service and your third party, so you kind of binded those two together for your app. Once it says, hey, I recognize you're Steve, I'm going to give I'm going to provide that token back to use, and it's going to make the call to the assume role with web identity to get the token, the STS token. Then your application would consume the STS token with the CLI or the SDK. Does that make sense? Okay. So, and then here's the slide for the Web Identity Federation. I'll let you guys look over that real quick. That's kind of what we just talked about. How are we so far? Has anybody lost totally? Questions, comments, threats? Okay. The different levels that you use STS, they will be covered on your developer exam, so make sure you pay close attention to those. Just remember that you always get authorized or authenticated with the third parties, whether it's ADFS or Google, Facebook, whatever. You always go to your third party to receive some sort of token or confirmation that you can do this, and then you get granted access into AWS services. Everybody follow? Cool, seeing some nods. All right, we're gonna go until it gets 2 o'clock, and we'll pick up from there. So the next service that we're gonna talk about is S3. Simple storage service. Who here has used S3? Okay, it's one of the most fundamental services provided by Amazon, and also one of the most powerful. A lot of AWS services are built on top of S3. S3 is object-based storage. Very cheap, by the way. There's different classes, but the standard, and we'll talk about the different categories of storage types, but the primary storage type is 6 cents a gig. I mean, so we're talking really low cost for S3 storage. So S3 is cloud-based object storage. By object, we mean files, pictures, not operating system, not databases, objects. So music is another example. It is highly available and redundant object-based storage in the cloud. It is a global service, but the buckets that you create are region-specific. It has unlimited storage, virtually unlimited. So you can keep adding objects, and Amazon is going to say, okay. Excuse me. So the components of S3 are buckets. Buckets are the containers in which you create to store your objects in. So think of them kind of like a root folder. Bucket names must be globally unique. So if you go out there and try to spin up a bucket called test, you're probably going to get an error stating that somebody else in the world has a bucket called test. That is not available. You can only have 100 buckets per account, and this is a soft limit. So soft limits with Amazon are limits they impose to kind of help keep you in place if you don't need a certain amount of things, but you can submit a ticket and ask for more capacity, and they will permit that. Or they'll review it and then usually permit it. Naming can only include lowercase letters, numbers, periods, and hyphens. No uppercases, and it can't start, I believe, with a period. But there are certain naming conventions to keep in mind with your S3 buckets, and if you make a mistake on that, it will tell you, and it won't let you spin up your bucket. Objects. So objects are the things that we put into our buckets. Now, let's talk real quick, because we talked about how buckets are kind of like your root directory. You can create other subfolders within a bucket. Now, they're not technically folders, but they're prefixes on a object name. So in the management console you'll see online, it will look like buckets, but in reality it might be FDB test bucket / folder 1 / 02 whatever today's date is / the object name. The way that we see it is a folder structure. The way Amazon sees it is the everything after the bucket name, between the bucket name and the file or the object name are prefixes. So keep that in mind.
Hey, I had a question.
Yes.
Is there a hard limit on the number of buckets that you have?
Not that I know of. From everything that they talk about and that I've seen, it's only soft limits.
Gotcha.
Now, after a certain number of buckets, you probably don't need any more buckets, but
Yeah.
that is a soft limit.
Gotcha.
Okay, so objects. The smallest object that you can have is 0 bytes. Keep that in mind. You can't have 0 byte files. So you may have a logging service and nothing gets written to that S3 file, but the file still gets created because the log needed somewhere to write it to. It may be a 0 byte file. The largest object that you can have is 5 terabytes. That's not a limit on the bucket, that is a limit on the single object. So no one object can go over 5 terabytes. The largest put object, or put operation for an object is 5 gigs. So keep in mind, AWS is Amazon's web services. These are just web API calls. So you have your gets, your puts, your deletes, option, head. The largest put operation that you can do is 5 gigabytes. And then you need to know the URL format, so let's pay attention to that, is your HTTPS, S3, then your region name, .aws.com, / your bucket name, / the prefix, and that could be several slashes in between like we talked about, and then your file name or your object name. You will probably get a question pertaining to, does this URL look correct? So know the structure of a URL. Good so far?
So on the prefix, if it was nested in our view of 3 folders deep, is that one prefix with all 3 in it, or is it considered 3 different prefixes?
There is only one prefix.
Okay.
But the prefix would have the several / the different what are they, domains, or the different levels would all be contained within that single prefix.
Got it.
Yes?
What's the difference between just available and highly available? Like, what makes this considered highly available?
So highly available, and we'll get into the availability here in a minute, but highly available means that it is accessible when you need it to be accessible. I know it's kind of a vague answer, and
They're measured in nines. So how many nines do you have? So it's 99.9 whatever percentage of the time that it's available.
Oh, okay.
yeah.
Okay.
And we'll get into the percentage of availability here. I think probably this next slide. Not the next slide, but it is in here. So let's cycle back to your question. Good? Okay. Object components, they have a key. That's your object name. The value, which is the data contained in that object. A version ID, if you have enabled versioning. And we'll talk more about versioning here in a minute. And then metadata. Some performance considerations that you may have is when you're storing objects, you can get hotspots in your storage, on your storage partitions. So S3 manages your object names lexicographically. So if you're seeing performance issues with retrieving your S3 objects, what Amazon recommends is putting at the front of the prefix some sort of random alphanumeric folder structure to spread out across the partitions where these objects are placed. So you may have 5 partitions, and if you have 80% of your objects on one, and I don't want to do math today, the other on the other partitions, you're going to get performance issues because it's got to scan all 80 of those to get to where it's to the object it's actually looking for. But if you could spread it across your partitions, and you don't manage the partitions, this is all under the hood, but if you see performance degradation on retrieving your S3 objects, then consider putting them in folder structures with that alphanumeric randomness. Does that make sense? Okay. Data consistency. So for the put of new objects, so I add a new file to my bucket, I have read after write consistency. That means that I can put it right in that bucket and I can call it immediately afterwards and it will be available for me. There is eventual consistency for overwrite puts or deletes. So I may update a file that is in an S3 bucket, and it may take a second or so to update. So I can't assume that I will get the same, or I will get the updated version the very instance after I do my update. Does that make sense? Okay. Remember those, you will be tested on that. HDTV error codes. So these should look familiar to anybody that's done any of the web API stuff. 200 is a successful, 300 is a redirections, 400 is client-side errors, and 500 are server-side errors. You will get part of the headers back on your request if you're doing things through the SDK or through the web API itself. You'll get these codes. All right, so we've got about 20 minutes left. Multipart uploads. So remember we talked about the cap on a 5 gig put operation. So if we have a 5 gig limit on my max put operation, but I can have a 5 terabyte file, there's some discrepancy there. So how do we bridge that gap? Amazon has a service for S3 called Multipart Upload. And let's cut over to the whiteboard real quick. Multipart Upload allows you as the user to take a large file, break it up into little chunks, and then send each chunk individually. So why might we want to do this? Let's say I've got a video. It's an MP4 file. And it's just an object. It's a movie, but let's say it's 2 gigs. Let's say it's actually 6 gigs. Let's exceed that limit. So I cannot do a single put request to put this object up there. It exceeds the 5 gig put limit. So what I want to do is I want to take this and I want to open a multipart stream. So open multipart, and then I break this up into multiple chunks. Or parts, as they're called. So this is part 1, 2, 3, 4, etc. And let's say that each of these are 50 megs. So I break up my object into my 50 meg pieces, and then I send them piece after piece. So I'll send piece 1, I then send piece 2, 3, 4, 5, etc. until I have completed the upload of all of my parts. So why is this beneficial? This can withstand some latency. So say that your internet connection drops out. This upload can pause. So I may have sent pieces 1, 2, and 3, but 4, I dropped internet connection. If I was trying to do a single put operation for even just a 2 gig file, and that happens, that will corrupt that file, and I would have to do an upload again of the whole file. It's a very slow process. I've done that. It's painful. Multipart is much better. Another thing is, say that parts 1, 2, and 4 get uploaded, all right, but part 3 got corrupted. Instead of having to upload the whole file, I can just upload this piece again. Once I get all my pieces, I then, let's call this 1, 2, upload my parts, 3, and then I close my multi-part connection. And what this service does is it takes all the pieces and you give it a piece number and it says part 1, then part 2, part 3, and it strings them all back together to get you your end file. So, yes?
How do you split the file up into, like, 50 meg pieces?
So when I've done it, I've written a little application to do some of this. I went in with a binary stream, and I binary streamed this chunk, and I sent the part, and I grabbed the next part, and so it's almost kind of like a skip over, take this next chunk, send this next chunk as a piece. Because each of these piece uploads is an API call. So I'm uploading a piece, and that's a API call. And then I move over my byte stream, and then I push the next bit, and the next, and the next. And then it combines them at the end. Good? Questions? Okay.
The stream couldn't hear that question at all, so they probably got the answer, but not the question.
Okay, so the question was, thank you. The question was, how do you break up the parts that you're going to upload? Good?
Yep.
All right. Yeah, thanks. Sorry.
No problem.
Kind of forget that. Okay, so break a file up into pieces, upload the pieces, and combine them in S3 to create the object. Objects over 5 gigs must be uploaded via Multipart. Amazon's recommended size for Multipart is 100 megs. I personally wrote an application to upload my pictures and some of the videos on my computer up to S3. I wanted to store off. And I had issues where I had latency between my internet connection, and oftentimes when I would push anything that's 102, 103, it would drop and it would fail. The Multipart was much more resilient. I was able to upload much more successfully. If a part didn't go through, it waited on the part, and then if it timed out, I could just reinitiate the part and push it up. So do yourselves a favor and kind of stick to that rule. It will be more resilient for your application. You can pause and resume your uploads. If a part fails, then you just re-upload that part instead of the whole object, and then it can be run in parallel. So your parts, you can bring out your parts, and then you can send them all up with the API calls, and then once you have them all up there, you can recombine them. Did I say a question?
Is there a recommended size of a part, or do you just sort of randomly pick in this whiteboard 50 meg?
So for this example, I picked 50 meg, but I think there is a minimum of like 10, and I don't remember if there's a maximum. I think the maximum may be 100. Pick something that you know will go, is pretty resilient in your application or within your infrastructure. So I noticed anything above 60, I was starting to get hit or miss if I was going to lose that connection or not. So I broke it into smaller chunks. Does that make sense?
And you say it runs in parallel, so you can send, you don't have to wait for one part to get sent before you can just run a whole bunch of parts at the same time. And at that part, programmatically, I'm thinking running in parallel. If one of them fails, you're going to be notified if one of them fails.
In your own application of how you break it apart, you would need to manage that. Mm-hmm. But what you can do is through the API call, if that fails, you'll get a message that part failed. And then you would re-upload that part. Does that make sense? Mm-hmm. Good? Okay. Storage classes. So there are 3 and kind of 4, and we'll talk about why the last one's a kind of storage classes for S3. We have S3 Standard, which is your standard implementation of S3. This is the highly available and highly durable S3 option. So this is where it's going into, we had a question about what does it mean to be high durability, and high availability. And it's the percentage of time that you can expect that object to be available, or what percentage of durability you can expect. So remember for S3, and this comes up in your exam, is the durability of an S3 object in S3 standard is the 11.9. So that is 9.999999999. Figured it was easier to say 11 nines. So remember that there's 11 nines of durability, and this is because under the hood, Amazon is actually redundantly storing your data in 3 different locations. So if one goes down, it can pick up from other 2. The likelihood that 3 different locations goes down is very slim. It is also highly available, so 99.99% of the time, you can expect to be able to retrieve your data. Good so far?
What does the 11 stand for again? I'm sorry.
99.99999. Yeah.
Yeah, there's 4 there. It's 99.99.
Those are different, right?
Yeah. There's a difference between durability and availability.
Oh, okay.
And then reduce the redundancy to use the same.
Yep, and we're going to talk about that. So,
so what happens in the one time that it isn't available? Is it just gone, or
The entire internet goes down.
oh, okay?
yeah,
Amazon had an issue last year. Yeah.
But they don't lose the object. It's just
No.
it's not available right at that second.
correct.
Okay.
Okay, so the second class is infrequent access. You would use this in cases that you want to save money on objects that require high availability and high durability, but you don't expect to access very often. There's a small fee incurred when an object is accessed. So let's talk about maybe a contract. We have a contract that we have negotiated and are we're good with. So the likelihood that we need to re-access that contract immediately is pretty low, but if we need to have it on hand immediately. So I don't expect to have to access it very often, but if I need to, I want it on hand. So you can save money with the objects that you don't expect to have to access often, but have to have available if you do. IA also has 11 nines of durability, but it is only available at 99.90% of the time. So those are the Amazon numbers, and I think it has to do with how like the bandwidth manages it. But yeah, remember the 11 nines durability for your IA as well. Reduce redundancy. So RRS, reduced redundancy is used to save money on objects that can be easily recreated. So reduced redundancy, instead of being duplicated in 3 locations, is only duplicated in 2. So you may use this kind of storage to save money on objects such as thumbnails. I may have an image from my website, and I may want to generate thumbnails. And I could use something like an EC2 server or a Lambda function to recreate my thumbnail. I want to save money by storing the thumbnails in RRS, because if I lose an object, then I could just have the Lambda recreate it and put it back into RRS again. There's actually a trigger in Lambda, and this is a little bit outside of the developer scope, but you can pick up if an object is lost out of a bucket. So it'll detect, I lost this object, it'll trigger your Lambda, it will recreate your thumbnail, and it will drop the thumbnail back into your S3 bucket. It is durable 99.99% of the time. This is because it's only stored on 2 locations and not 3. And it also has availability of 99.99%. So 99.99% of the time should be available. And the fourth kind of S3 service, it's actually its own service, but it is closely coupled with S3, is Glacier. So Glacier is long-term cold storage at a greatly reduced cost, but a very slow recovery time. So think about 3 to 5 hours. It is used to archive S3 objects, and it also has 11 nines of durability. So when would we maybe want to use a Glacier vault? Let's say that we have, we're a doctor's office, and we have seen a patient, we haven't seen them in 6 months, and we don't, maybe this specific visit, or they canceled with us. They're no longer a customer of ours. But for compliance reasons, we need to keep their data for 7 years. Well, I don't expect to have to access it quickly. And if I do, I probably have 24 hours to get that data back. I would store it for those 7 years in Glacier and save on the cost because I don't need access to do it, and it's really for compliance reasons. Does that make sense?
Real quick question.
Yes.
What's the difference in cost versus the standard S3 buckets and the IA? So how much cheaper is the infrequent access versus standard?
So you'll never actually be asked the cost on the exams, but to answer your question, I believe it's 6 cents for standard per gig. It's 4 cents, I believe, per infrequently accessed. And I think for Glacier, I think it's like 2 cents a gig.
Is that a monthly?
Yes, monthly. And there's also throughput costs. Check out their website and their page on that. I think it's a little bit different per region as well. But if for pricing info, check out the page. Okay. We've got 5 minutes. We're gonna stop it there for We're gonna stop it there for today. So we're gonna end off on the lifecycle policies. I'm gonna open up the floor to any questions, comments. Anybody have questions?
Do they ask a lot of questions about how, like, it gives you a scenario and then you create a policy, like an IAM policy?
So the question was, on the exam, are you expected to be able to handle scenarios in which you have to create your own custom IAM policies, correct? Not for your developer exam. When you get more into your SysOps exam, when you get more into the solutions architect, you're expected to know a little bit more of that. For the most part, pertaining to policies on the developer exam, you need to know what they are and kind of the basic information about them. You don't really get into the complex IAM policies until later down the road. You definitely get into them in the professional levels. Are there any other questions? All right. Well, I think we'll stop there then. The goal, this is kind of an ambitious goal, I get that, but we're trying in 5 hours to cover this whole exam. So bear with me on time a little bit. Sometimes we may run under, sometimes we may run over, but yeah, we'll pick back up on lifecycle policies tomorrow. All right. Thanks, everybody.
Thank you.